Combinations, choices or selections. Part 1. In how many ways can 4 different cards be chosen from a standard pack of 52 cards? Number 2. How many of these choices contain the King of Diamonds? So let's start with part 1. In how many ways can 4 different cards be chosen from a standard pack of 52 cards? Well, there are 52 cards and we are choosing 4. So the number of choices is 52 choose 4, which is really 52 times 51 times 50 times 49, all divided by 4 by 3 by 2 by 1, which gives us 270,725. Now you don't have to do it out the long way each time. The calculator has a button for it. It's usually a C. So it might come up 52C4, but I just wanted to do it out the long way so that you know what it actually means. So it's really 52 times 51 times 50 times 49 divided by 4 factorial. Part 2. How many of these choices contain the King of Diamonds? If the King of Diamonds must be one of the cards chosen, then we really only have to choose 3 cards from the remaining 51. So we're left with 51 cards because we take for granted that one of the cards chosen is the King of Diamonds. So 52 take away 1 is 51. And it's 51 choose 3 because remember we were asked in how many ways 4 cards can be chosen in part 1, but we're taking for granted that one of those cards chosen was the King of Diamonds. So therefore 4 take away 1 is 3. So we've got 3 left. So our number of choices is 51 choose 3, which is 20,825. In how many ways can we choose 3 or 4 or 5 cards from a standard pack of 52 cards? Well, there are 52 cards and we have to choose 3 or 4 or 5 cards. Remember, in probability, OR means add. We will need to use the second fundamental principle of counting. OR means we add. So let's start off with the 3. We want to choose 3 from 52 or 4 from 52 or 5 from 52. So our number of choices are going to be 52 choose 3 plus 52 choose 4 plus 52 choose 5, which gives us 21,100 plus 270,725 plus 2,598,960, which gives us 2,891,785. Part 1. How many choices of 4 letters are possible from the letters of the word minerals? So we have to choose 4 letters from the 8 letters of the word minerals. M-I-N-E-R-A-L-S. We have 8 letters in total. So our number of choices is 8 choose 4, which is 70. Part 2. How many choices of 4 letters contain 2 vowels and 2 consonants? Because the question refers to 2 types of object, vowels and consonants, we have to divide all letters into 2 groups. There are 3 vowels, I, E, A, in the word minerals, and 5 consonants, M, N, or L, S, again from the word minerals. So we have to choose 2 vowels and 2 consonants. Remember, and means multiplying probability. We will use the first fundamental principle of counting to find the total number of choices, and means we multiply. So we want to choose 2 from 3 vowels and choose 2 from 5 consonants. So our number of choices will be 3 choose 2 multiplied by 5 choose 2. 3 choose 2 gives us 3, 5 choose 2 gives us 10, and 3 times 10 is 30. Number 3. How many choices of 4 letters contain at least 1 vowel? If a choice has to contain at least 1 vowel, then it can contain 1, 2, or 3 vowels. Remember, we only have 3 vowels in the word minerals: I, E, and A. We could calculate each of these and then add by the second fundamental principle of counting. However, a faster way is to calculate the opposite and subtract from the total, which we already know is 70. This is from the previous question. The opposite of at least one vowel is no vowel. To pick no vowels, we must pick all 4 letters from the 5 consonants. So what do we want? We want to pick 4 letters including at least one vowel, and the opposite of that is that we pick 4 letters with no vowels, i.e., that is, pick 4 from the 5 consonants. So number of choices for the opposite is going to be 5 choose 4, which is going to give us 5. And the number of choices for what we want is going to be 70, which is the total from the previous question. Take away the 5, which leaves us with 65. Determine the value of n, which is an element of the natural number set, positive whole numbers, if n choose 2 is equal to 78. So we need to figure out what this n value is. So n choose 2 equals 78. So we can rewrite n choose 2 as n times n minus 1 all over 2, which is equal to 78. Because remember, we minus 1 each time. N by n is n squared, n by minus 1 is minus n. This is all over 2 equal to 78. So to get rid of the divide by 2 part, we need to multiply across by the 2. So 78 by 2 is 156. So we have n squared minus n equals 156. Bringing the 156 over the equal sign, it becomes minus 156. Factorizing, we get n minus 13 times n plus 12. And then solving, n minus 13 equals 0, so n is equal to 13. Or n plus 12 is equal to 0, so n is equal to minus 12. As n is an element of the natural number set, which means it's positive, the answer is n equals 13. So this is really 13, choose 2, and 13 choose 2 will give us 78.